What's A? B? C? You said it positive, so it's up like a cup. So it's we have a vertex that'll be a minimum. To find the x value, or for the the axis of symmetry, it's always x equals, because it's a vertical line, opposite of b over 2a. I recommend writing that out a couple of times as you're filling these things through, just so that way it sticks in your head. You won't forget it. So opposite of negative 12 is 12, and 2 times 2 is, so our axis of symmetry winds up being at 3. So far, so good? Okay. Now, when you go to plot these things, we know the first thing is to have that axis of symmetry will be located at 3. How do I find the y value for that then? Yes, ma'am. Perfect. Remember, this is the x coordinate of your vertex. Your vertex always, and guess what? Always lands on the axis of symmetry, which means your x value will always be the x coordinate of the vertex. So you substitute in, let's see, 2, 3 squared, 12 times 3 plus 19. All right, what's 3 squared? 9 times 2? Okay, 18 minus 36. Add 9. Negative 9. 19, so it'll be negative 8, right? I should try to do this in my head. It's, how about 1? Don't listen to Trinity. What? Nothing. You were wrong. Yep. Anyway, so we have our first set of ordered pairs here. Okay. So when you start going back and forth, does it matter which side you choose to work with? Nope. What I would probably do is I would probably use 1. Why would I use 1 and not 2? It's easier. It's easier because I already know that I have a symmetric twin that I can get from the y-intercept, from the c value. Since I'm relatively close to it, it's not a big deal. So might as well use 1 because it's just an easier number to multiply. Do you have to use the 1, or can you use 2? Can you use 4? Just whatever you want. It doesn't matter. I would just go with the 1 because hopefully I can do that in my head. No promises. So 2 minus 12 is negative 10. Negative 10 plus 19 is 9. All right, so at 1, it's 9. So we'll say that's here. Just not scaling it. Not to scale, as you say. So what's the symmetric twin then for 1? Remember, it's 2 away. So it's got to go 2 away over here, so it's at 9. 5, 9. All right. And then lastly, I would use my y-intercept c value. That was at 0 and 19. And then the next one would have been at 6 and 19. So those would be my ordered pairs. And there's my happy curve. Yay. Did this have any zeros? Remember when you guys had, when you did factoring stuff, if it wasn't factorable? That's because there weren't any zeros. They're imaginary. There's a whole other thing of math that's going to happen next week. We can think about it, but we can't talk about it. We can think about it, can't talk about it. I'm not saying anything about it, though. I'm just thinking about it. I don't know what you're talking about. Don't roll your eyes. Okay? Standard form. Other form we did was vertex form. Now, when we did vertex form looked a lot like when we graphed absolute value. It looked a lot like when we graphed absolute value. Remember when we graphed that beginning of the year, we had stuff like where it was y equals 1/2 absolute value x minus 2 plus 3. If I had that, that told me where did my graph start. This started at 2, 3. Okay? And then what was my a value? The a value acted as its slope. Okay? It was its multiplier. Was that a value is 1/2 positive or negative? So which way did that v open? Hey, is that coincidental? Okay. So the idea here with the vertex form, same basic principle. A is positive, it's up like a cup, you have a minimum. A is negative, it's down like a frown, and you have a max. Your vertex lies at the coordinate hk, always. And where's your axis of symmetry? At h. Your axis of symmetry is always at x equals h. So those are actually really, really, really nice to work with. Okay? There's a lot less having to figure out where the axis of symmetry was and going through there. So if we look at one of those, two sets of different PDF. It's really weird. Huh. Oh well. So if we look at one of those, we did what? Well, let's look at 28. Actually, let's do a fraction. Let's do a weird fraction. All right, last one. Let we'll do it on your own. Wow. So you want to use some of the blank paper I have in the back to help yourself? Yeah, plenty. Okay. All right, it's fine. But that's a whole philosophical thing that's changed. It's really starting to change. I think probably by your, depending upon where you wind up, school district wise, I give it for 3-4 years and they're probably all standardized. Nothing. Stop smiling. What are you whining about? I'm sorry it's boring. We haven't gotten the word problem. Is it like one-time word problem? Yeah. See, I'm not wrong. I didn't say you were right. Yep, I'm right. I got A, P, and Q, 1/3, -4, -1. Everybody agree, disagree? Yeah. Okay. So that tells me it is up like a cup, and I should have a vertex that is a minimum. Okay? So as we start working through, -4, -1 gives me zeros. What occurs halfway between my zeros? The axis of symmetry, which is at -2.5, you said? Okay. So my axis of symmetry is at -2.5. So there's my x coordinate. Okay. Throw that into the throw that into your equation. -2.5 plus 4 is 4.5. Or sorry, 1.5. So we have 1/3, 1.5 is 3/2, and then 1 plus -2.5 would be -3.5. So -3/4. Okay. You got negative 3/4 for your y value?
Zero.
What are you talking about?
Oh, wow.
This is a time when the fractions are a lot easier to work with than decimals. If you have negative 2.5 plus 4 gives you positive 1.5. 1.5 is 3/2, right? Okay. And then you take negative 2.5 and you add 1, you get negative 3/2 as well. So if you list out your fractions, you have 1/3 times 3/2 times negative 3/2. Well, if you know a little something about fractions, this happens and you get negative 3/4, and it's a lot faster than knowing how to do anything else. Because when you multiply fractions, you're multiplying straight across. So you get 1 times 3 times negative 3 in the numerator, 3 times 2 times 2 in the denominator. The one set of 3's dropped. Because it's a set of 1. Because this means 3 divided by 3 is 1. Remember when you did polynomials?
No. I don't remember anything about algebra 1 because
You would cross those out. Same basic idea. Okay. Anyway, guys. So you've got your vertex at negative. And then in this case, you can either use obviously negative 2. I would probably just use 0, just because it looks like it'd be a little bit cleaner to work with. If I use 0, I get 4 times 1 is 4 times 1/3 is 4/3. So then I'd have that a little bit above here, and that is 1, 2, about here-ish. So my ordered pairs, I'd put them. We have negative 2.5, negative 3/4 for our vertex. Our zeros were at negative 1, 0, negative 4, 0. And then we said at 0, 4/3. Well, that was 1, 2, 3, so it'd be 1, 2, 3, so that was at what? Negative 5. Okay. So, same section tonight. The problems I want you guys to look at, though, the instructions are different. I don't want you to rewrite anything ever into standard form. That's a waste of time. There's no reason to do that. What I want you guys to do is just practice some graphing ones. So let's do, let's see, I want to make sure we get a mix of all types. One, 2, 3, let's do this. Did that go through? Yeah. So in this one here, let's see, we got 1, 2, 3. Cross off this one. You do that in those. Oh, there aren't any. Get rid of this one. All right. There aren't any standard form ones. I think those are the styles you guys are most comfortable working through. These are the most common ones. Yes, sir. Is this the same page you were doing yesterday? If you want, I would just take a picture of it. It's just, but I don't want you guys to just graph. I know the instructions are going to say write in the standard form. Just graph. Okay. All right. Same way we've been doing. It gives you 6.